Good afternoon. My name is Faria, and I'm from Águas do Norte. My project name is named Producing Water for Irrigation, a wetland as a quaternary treatment unit. Águas do Norte represents about 84% of the north region of Portugal and covers 63 municipalities providing water supply and wastewater sanitation services. Some numbers. You can see our facilities we have in the water supply system, 16 dams, 43 water treatment plants, and in the wastewater sanitation facilities, we have 182 wastewater treatment plants, and we have about 1,700 kilometers of pipelines installed. So we have a big dimension in the area. This study was performed in Agra Wastewater Treatment Plant. It's located in Vila Nova Famalicão. It's between Braga and Porto. And this is the big plant that treats approximately 44,000 cubic meters a day. The effluent has high industrial component from the textile sector, but mainly the agri-food sector like food waste processing, animal production, slaughterhouses, and landfill leach discharges. This plant has a secondary treatment by activated sludge and as a tertiary treatment. Near to Agra, as you can see in the photo, we have numerous plots, agricultural plots that can be using the reclaimed water. So, what was our motivation? We had an existing landfill that was never used, and we have the opportunity to convert him into a phytosanitary wastewater treatment plant, testing nature-based solution in wastewater, following the requirements of the new directive concerning wastewater treatment, and in the scope of the targets defined for irrigation water, which Grupo Águas Portugal was called to respond. So the objectives. This project was founded by the Life Plus program and in partnership with Vila Nova Famalicão municipality. And the companies that was addressed to Águas do Norte was Action C3, the rehabilitation works from the sludge landfill into a quaternary treatment. You can see on the right side the existing sludge landfill that was never used. And Action C4, communication, governance, and result replication activities. So, the innovative component of this project focused on assessing the pond performance as a quaternary treatment unit. We have in the table the criteria for the national criteria for reclaimed water and the parameters we studied and the criteria we are trying to achieve in the moment. So we intend to remove the residual load of the effluent, and we intend to support the surrounding ecosystem. In the future, we intend to evaluate the performance of the pond by analyzing all of the color, also the color removal and the removal of emerging pollutants. So here, it's too fast for me this. Here we can see how it was the existing landfill, the construction works, and the wet plant in full function. This is the main activity of the project. So this is Agra Wastewater Treatment Plant. In the right, we have line 1. At the end of line 1, the tertiary treatment, we have the pump station 1 that sends the water to the initial phase of the wet plant, and then the discharge is made by pumping if the level is lower, or by gravity if the level is higher. So the startup of the facility was initiated in May 25, and the operational settings were tested. The pond level and the hydraulic retention time. Grab samples were collected, and the electronic supervision of the system enables the hourly inflow rate to be set until the daily volume is reached. We can only talk about preliminary results here because we started with a short time of study. So we can say for BOD5 and total phosphorus, the values at the entrance of the pond already comply the objectives established for Class D. The same applies to parasite head parameter. So we can say that ensuring an effective tertiary treatment of agra plant is enough for the compliance of these three criteria. Regarding ammoniacal nitrogen, reducing the effluent flow rate had positive effects on removal efficiency. In some cases, similar effect was also observed with increasing hydraulic retention time. For total nitrogen, reducing the effluent flow rate had a positive effects on removal efficiency, whereas increasing hydraulic retention time appears to have decreased the removal efficiency. However, the legislation we have in Portugal says that total nitrogen and ammoniacal nitrogen are optional parameters once they can be beneficial to some cultures. For E. coli, it appears that longer hydraulic retention time favors the removal efficiency. The initial values still reflect a treatment stage in which the plants had a poorly developed root system. So during this time of study, it was not yet possible to observe the effects of the liquid high, promoting the pathogen inactivation through the UV radiation. You can see now in this picture and the picture before that we have a square between July and September. And in this time of the year, normally, the profiles changes for total nitrogen, for ammoniacal nitrogen, and for E. coli. This pattern can be related to the increase of the temperature and to the changes in the effluent characteristics, because agra is a plant that has high industrial component, and in the beginning of August, the industry starts cleaning the equipment and then close in the last 15 days of August. Main challenges in this project, we have a big challenge, several challenges, but the first one was the biggest. Adverse weather conditions between November 25 and February 26, with high precipitation in the region that floated the plant and caused the uplift of the liner, as you can see in the photo. And these effects were aggravated by the high groundwater level in the area. Then we have to ensure the staff safety and the safety during the annual plant cutting. This challenge has already been solved. So conclusions, we cannot yet redraw very big conclusions because it's the initial stage of the study, but the plants installed in May 25 are now approaching maturity. We can see roots about 50 centimeters long, but more results are required to support the efficiency of the project. The results for BOD5, total phosphorus, and parasite eggs comply with the criteria for national legislation. The main challenge has been targeting the values for total nitrogen, ammoniacal nitrogen, and E. coli. And oxygen profile will be established along the pond, and based on this, the most effective strategy to promote nitrification and denitrification will be assessed. Once the Portuguese legislation mentions that total nitrogen and ammoniacal nitrogen are optional parameters, E. coli is expected to be the central focus of the study in short term. In the future, we intend to optimize the operation conditions, the hydraulic retention time, and the pond water depth. And the next step will be assess the dissolved oxygen profile, to enhance the natural UV disinfection, and to investigate the removal of emerging and persistent contaminants, as well as the removal of the color. Thank you very much. Any question, please?